Welcome to the Fox Learn. Humans are model builders. We create models of the world to manage complexity and to help us understand problems we're trying to solve. You see models all the time. Street maps are models of roadways. Globes are models of the Earth. Atomic models are models of the interaction of subatomic particles. Models are simplifications. There is little point to a model that is as complex as the object in the problem domain. A good object-oriented design is an accurate model of the problem you are trying to solve. Look at your computer. You do not see various bits of plastic and glass amorphously merging with the surrounding environment. You naturally and inevitably see distinct things: a computer, a keyboard, a monitor, speakers, pens, paper. Things. More importantly, even before you decide to do it, you've categorized these things. You immediately classify the computer on your desk as a specific instance of a type of thing. This computer is one of type computer. This particular pen in your pocket is an instance of a more general type of thing, pens. When you define a class, you describe the characteristics and behavior of objects of that type. In C#, you describe characteristics with member fields. Member fields are used to hold each object's state. For example, the state of the dog is defined by its current weight and name. The heart of object-oriented design is establishing relationships among the classes. Classes interact and relate to one another in various ways. The simplest interaction is when a method in one class is used to call a method in a second class. For example, the manager class might have a method that calls the update salary method on an object of type employee. This process of aggregation, or composition, allows you to build very complex classes by assembling and combining relatively simple classes. The .NET framework provides a string class to handle text strings. Object-oriented programming is built on three pillars: encapsulation, specialization, and polymorphism. Each class should be fully encapsulated, that is, it should fully define the state and responsibilities of that type. Specialization allows you to establish hierarchical relationships among your classes. Polymorphism allows you to treat a group of hierarchically related objects in a similar way and have the objects sort out how to implement the programming instructions. Encapsulation. The first pillar of object-oriented programming is encapsulation. The idea behind encapsulation is that you want to keep each type or class discrete and self-contained so that you can change the implementation of one class without affecting any other class. A class that provides a method that other classes can use is called a server. A class that uses that method is called a client. Encapsulation allows you to change the details of how a server does its work without breaking anything in the implementation of the client. Specialization. The second pillar of object-oriented programming, specialization, is implemented in C# through inheritance, specifically, by declaring that a new class derives from an existing class. The specialized class inherits the characteristics of the more general class. The specialized class is called a derived class, and the more general class is known as a base class. The specialization relationship is referred to as the is-a relationship. A dog is a mammal, a car is a vehicle. Dog would be derived from the base class mammal and car from the base class vehicle. Polymorphism, the third pillar of object-oriented programming, is closely related to inheritance. The prefix poly means many, morph means form. Thus, polymorphism refers to the ability of a single type or class to take many forms. Sometimes you will know you have a collection of a general type, for example, a collection of controls, but you do not know, or care, about the specific subtype of each control. The important thing is that you know they all inherit shared abilities and that you can treat them all as controls. Before you program anything, other than a trivial demonstration program, you need to take two steps: analysis and design. Analysis is the process of understanding and detailing the problem you are trying to solve. Design is the actual planning of your solution. With trivial problems, such as computing the Fibonacci series, you may not need an extensive analysis period, but with complex business problems the analysis process can take weeks, or even months. Once you've analyzed the problem, you design the solution. Imagining the classes you will use and their interrelationships is key to the design process. You might design a simple program on the fly, without this careful planning, but in any serious business application, you will want to take some time to think through the issues. There are many powerful design techniques you might use. How much time you put into design before you begin coding will depend on the philosophy of the organization you work for, the size of your team, and your background, experience, and training. Object-oriented programming helps programmers manage complexity by modeling essential aspects of the real-world problem. A class defines a new type in your program and is typically used as a representation for a type of thing in the problem domain. An object is an instance of a class. State is the current condition of an object. Many classes define member fields, which are typically private variables visible to every method of the class, but not outside the class. The behavior of the class is defined with methods, which contain code to perform an action. Methods can manipulate the state of the object and interact with other objects. The three pillars of object-oriented programming are encapsulation, specialization, and polymorphism. Encapsulation requires that each class should be discrete and self-contained. Each class should know or do one discrete thing or set of things. Specialization is implemented by deriving more specific classes from generalized, base, classes through inheritance. Polymorphism allows you to treat a collection of objects of types, all derived from a common base, as though each was an instance of that base type. Analysis is the process of detailing the problem you're trying to solve. Design is the planning of the solution to the problem. Thank you for watching this video.